Was I going faster or slower than 19 miles an hour? At 200 feet, I'm probably going faster, yes? Now, you see these lines right here? What those lines are called are secant lines. Don't have to memorize this. Don't have to memorize this. They're called secant, S-E-C-A-N-T. Remember that word tangent from the angle chart? Michelle's like, I'm trying to forget it, thanks. The tangent is a trigonometric idea. It's one of those words that applies to angles and their measures. And we're going to come back to that word tangent in a second, because it actually, believe it or not, it applies to this as well. There are other words in trigonometry that talk about other measures of a triangle. Sine was one we talked about in class, opposite over hypotenuse, or rise over hypotenuse. There's a cosine, which is the run over the hypotenuse. Then there's something called a secant. Something called a secant. Now don't worry about what it's defined as. Here's what it is geometrically. It's what happens when you take a point on a curve and a second point on a curve, connect them. That's called a secant line. Now what you're seeing is the average rate of change is defined by the slope of that secant line, and that's fantastic. It's perfect, perfectly set. The problem is, where does our secant line need to be? Well, it needs to be closer. It needs to be closer to this point, doesn't it? I heard the vote for 0, 0. We know the answer to that one right now. What was my speed right here?
0.
At 0, it was 0. Now, I know that's kind of coincidental because these are both equal to 0, but you couldn't do the math on this. Here's why. Here's why. Imagine trying to do the secant line that's right at that point. In other words, I need 2 points, yes, to calculate the slope. So both the points would be 10, 3, 200. What would happen if you try to calculate a slope with just 1 point? You get 0 over, which would be what? Undefined. You get 0 over 0. y2 minus y1, 200 minus 200 is 0. You haven't gone anywhere. Seconds? x2 minus x1, 10.3 minus 10.3, you wouldn't go anywhere, right? So the question then becomes is, how can you approximate that as you get close to it? We're on our way right here. Why don't we just scooch this point closer? That line's going to get steeper, right? That line's going to get steeper if we scooch it closer. Let's scooch it over to 7.5 seconds, shall we? 5, 6, 7.5. 7.5 seconds. How far is it there, that distance right there at 7.5 seconds? I don't know. Well, that's what we're using. Using a table. I get 110.5 feet. Check me on that, friends. So now we're roughly at the halfway point distance-wise, a little bit past it. But we're also 3/4 of the way done the time. So we're starting to pick up speed now. We're starting to pick up speed. Yeah. What's my average rate of change, or my average speed? What's my average speed between, let's look yellow, here and here? What's my average rate of speed there? Now, what I'd like to do is I'd like to show you guys a trick, if it's okay. I'd like to show you guys a trick, a TI trick, to do the math you're already doing. Because I know what you guys can do right now, yes? You can very easily just go that minus that over that minus that. Some of you may have already done it, yes? Francis, you already did it. What number did you get?
I got 89.5 feet over 2.8 seconds.
So that's about 45 feet per second-ish? Somewhere there, some in the neighborhood. Go ahead and do the division for me.
Okay.
Ish.
32.
Oh, I overestimated. 2.5.
31.9.
Thank you. I did 2.2, not 2.5. It's a big difference. So good, 32 feet per second. And that's fantastic. You can totally do that. But what I want to do is I want to show you a TI shortcut. You put the whole calculation in the TI, and here's why I like doing it this way. So work with me here. Stay with me on this one, because it's a bunch of button pushes at the start. No, it is. But the thing is, once you do it once, you never have to stop doing those button pushes.